Welcome to Early Wisdom Academy. Real numbers, chapter number 1. To understand what are real numbers, you should know what are natural numbers. Natural numbers are the numbers that starts from 1, 2, 3 and so on. So rational numbers are also called as counting numbers because when I count anything, any object or anything, I start counting it from 1, 2, 3 and not from 0, 1, 2 and 3. I am not going to say it as 2 stars, that is 0, 1, 2. I always say it as 3 stars because 1, 2, 3 are the numbers which I use for counting. So these are called as the natural numbers. So when I include 0 for this natural number, I get a whole number. When 0 is included to the natural numbers, I get whole number. So when I include negative numbers, I get integers. They are the integers. So apart from negative numbers 0, 1, 2 and 3, I also have decimal numbers or fractions. They are called as rational numbers. Okay. I also have irrational numbers. Irrational numbers are in the form of root 2, root 3, root 7. All these are irrational numbers. These numbers and irrational number together, they are called as real numbers. They are called as real numbers. Let us understand what are rational numbers and irrational numbers. Rational numbers are the numbers which can be represented in the form of p by q, where q is not equal to 0. The denominator should not be equal to 0. Say for example 7 by 5, 5 by 3, 9 by 19. So all these are rational numbers. I can even write 36, that is 36 by 1 is also a rational number. Next, coming to the irrational numbers. Irrational numbers are the numbers which cannot be represented in the form of p by q. For example, is root 2, root 3, root 4. Root 4 is not a irrational number because root 4 is equal to 2. I can write it as plus or minus 2. Whether it is plus 2 or minus 2, it can be written in the form of p by q by writing the 1 in the denominator. Therefore, this forms a rational number and not a irrational number. Then, is it necessary to have only prime numbers under the root to have an irrational number? No, because 15, okay, 15 is not a prime number because 15 has a factor as 1, 3, 5 and 15. It has more than 2 factors, therefore 15 is not a prime number, but still root 15 is a irrational number. Therefore, it need not be a prime number which is under the root to form the irrational number. Then what is the condition you should remember while finding an irrational number? It is necessary that square root of a perfect square is always not a irrational number because 4, you know, it is a perfect square. Square root of a 4 forms rational number. Similarly, square root of 36 is equal to plus or minus 6, which is again a rational number. So you should remember perfect square which is under the root is always not a irrational number. Okay. Point in irrational numbers. Another point to be added for irrational numbers is recurring and non-repeating. There is no pattern in it. So such numbers are always irrational numbers. Okay. It should be recurring. For example, 1 0 1 0 0 1 0 0 0 1 0 0 0 0 1 and so on. It is recurring. It is going to continue. They are not repeating. Say for example, what is repeating then? 0.12369369 369. So this 369, when I say there is a bar, this 369 is continuously repeating. So such numbers are called rational numbers and they are not irrational numbers. When recurring or when they are repeating, non-repeating and recurring, we call it as irrational numbers. So all these numbers comes under real numbers. So the next topic is composite and prime numbers. So first, what are prime numbers? Prime numbers are the numbers which has the factors as 1 and itself. It has the factors as 1 and itself. For example, you can say 2. 2 has the factor as 1 and 2. Say 7, it has the factor as 1 and 7. It is going to have the factor as 1 and itself. Say 19, it has the factor 1 and 19. So all such numbers are called as prime numbers. Other than these numbers, other than prime numbers, they are called as composite numbers. Okay? Composite numbers has more than 2 factors. It has more than 2 factors. Previously we saw 15 is a composite number. When I say it is not a prime number, then it is a composite number and it has the factors as 1, 3, 5 and 15. More than 2 factors. Therefore, it is a composite number. Then what about 0 and 1? Even these are the numbers, right? 0 and 1 are neither composite nor prime number. They come under not a composite number, not a prime number. So next, prime factorization. Let me consider the number as 300. The prime factorization is, first let me consider the smallest prime number, that is 2. 300 is an even number as it is ending in 0. So it is divisible by 2. So 15s are 30, so I have a 0. Then 2, again 150 is divisible by 2. 7s are 14, 5s are. Then the next prime number is 3. 3 2s are 6, 5s are 15. The next it is divisible by 5, 5 5s are. So 5. So 300 has the factors as 2 square into 3 into 5 square. This is your prime factorization. Next is LCM and HCF, least common multiple and highest common factor. Let us consider the example as 315. Okay. To find the LCM of these two numbers, I am going to write it in this format, 300, 15. So this is easily divisible by 3, 100 and 5s are. So next, these numbers are easily multiple by 5, right? 5 2s are, 5 1s are. Then 20 is multiple by 2, 2 5s are and 5 and 1. So LCM is equal to 3 into 5 into 2 into 5. Okay, on multiplying this, what will have? 5 3s are 15, 2 2s are 4, 4 5s are 20. So it is, again you will get 300 as your LCM. LCM is 300. Next, to find HCF, I am going to prime factorize each numbers separately. Okay, 3 hundreds, 5 20s are, 2 10s are, 5 2s are. Similarly, 5 3s are, 3 1s are. I have 2 1. So I have a 3, I have a 3. So for HCF, I am going to take only the common factors. 1 3. I have a 5, I have a 5 into 5. 5 3s are 15. 15 is my HCF. Okay, the numbers are repeating, but this is the method to find LCM and HCF. A common error while finding HCF is there is 2 5 in 300 and single 5 in 15. So there is a chances of considering as 25, that is 5 square. No, it should not be taken. 1 5 for this and this 1 5, this 1 3 and 3. If in case I have another 3 or another 5 here, I can take these 5 again. That is 5 into 5 is 25 and into 3, that will be your HCF. Just see how many times it occurs common to both the numbers. That is your HCF. LCM and HCF. LCM is always a greater number. HCF is always a smaller number. You should remember this. LCM is a greater number. HCF is a smaller number.